Hello and welcome. Today, we are diving headfirst into a moment in medicine that feels like it's straight out of science fiction. We're witnessing a complete revolution, an era where diseases we once thought were a life sentence they might finally have an expiration date. We're moving beyond just managing symptoms. We're talking about fixing what's broken at its absolute source. And that brings us to the huge question we're going to explore today. Seriously, think about this. Have we actually reached the beginning of the end for incurable disease? I know, it's a massive idea, but the technologies we're about to walk through, they suggest the answer could very well be a resounding yes. For most of modern medical history, the game plan for chronic illness was management, control the symptoms, slow things down. But that era, it's coming to a close. The entire paradigm has shifted from just managing to actually correcting. We're not just treating diseases anymore. We are starting to cure them by editing our own DNA with a technology you've probably heard of called CRISPR. So let's jump right in with its first blockbuster success. Okay, our first stop is one of the most incredible wins for this new era of medicine, a functional cure for sickle cell disease. This is a brutal, painful genetic blood disorder that affects millions of people around the world. And the therapy that's changing everything for them is called CASGEVY. So what is the magic behind this? At its core, it's CRISPR. And, the concept is so beautifully simple. Imagine your entire DNA is a massive instruction manual for your body. Well, CRISPR acts like a biological find and replace function on your computer. It can scan through billions of letters of genetic code, find one single misspelled word, a faulty gene, and edit it with unbelievable precision. Now, CASGEVY is what's called an ex vivo therapy, which is just a fancy way of saying the editing happens outside the body. Here's the play-by-play. First, doctors take a patient's own blood stem cells. Then, in a lab, they use CRISPR to do something really clever. Instead of trying to fix the broken sickle cell gene, they just switch off a different gene, one that normally tells our bodies to stop making healthy baby hemoglobin after we're born. With that switch flipped off, the cells start cranking out the good stuff again. Finally, these newly edited, superpowered cells are infused right back into the patient. And the results? Honestly, they are stunning. For people with sickle cell, this treatment led to the near total elimination of the horrific pain crises that define the disease. And for a related condition, beta thalassemia, a mind-boggling 91% of patients didn't need constant blood transfusions anymore. This isn't just treatment. This is a functional cure. But, and this is a big but, this revolution has a jaw-dropping price tag. One single dose of CASGEVY costs $2.2 million. Now, that number reflects the unbelievable science that goes into it, but it also forces us to ask a really tough question. Who gets access to these cures? The science is moving at light speed, but the economics, that's a huge mountain we still have to climb.
All right, so editing cells in a lab is amazing. But what if you could skip that whole step? What if the genetic surgery could happen directly inside the human body? Well, that is the next frontier, and it's called in vivo gene editing. The difference between these two approaches is just massive. With ex vivo, outside the body, you have to take cells out, edit them, and then put them back in. But with in vivo, inside the body, the CRISPR machinery gets packaged into what you can think of as a microscopic biological delivery truck. It's infused straight into the patient, it travels to the right organ, like the liver, and it performs the genetic edits right there, on site. It is a huge leap forward. And the first major disease in the crosshairs for this in vivo approach is a truly devastating one called ATTR amyloidosis. This is a condition where a single faulty gene makes the liver produce a toxic, misfolded protein. That protein then builds up in the nerves and the heart, eventually causing total organ failure. It's progressive and it's fatal. So, to combat this, a company called Intellia Therapeutics developed an in vivo therapy, a single infusion, one and done. And the results from the trial? A stunning 93% reduction in that toxic protein. This isn't just managing the disease. This is literally reaching into the body and turning off the faulty gene at its source. But as with any true pioneering effort, the road to a cure is never a straight line. In late 2025, the trial was put on hold by the FDA after a patient who already had very severe health problems passed away. It was a really scary moment, a major test for the entire field. But after a very thorough review, in early 2026, the FDA lifted the hold, saying the research was safe to move forward.
It's a powerful reminder of both the incredible promise and the very real risks of creating brand new medicine. Okay, let's switch gears and talk about another one of medicine's biggest enemies, cancer. In this fight, CRISPR isn't just fixing broken genes, it's being used to create something entirely new. We're talking about a living drug made by supercharging our own immune systems.
This is called CAR-T therapy, and the idea is basically to weaponize a patient's own immune system against their cancer. Scientists take out T cells, which are like the natural soldiers of your body, and they use CRISPR to give them an upgrade. They install a new piece of equipment called a chimeric antigen receptor, or CAR. This CAR acts like a heat-seeking missile system, allowing the T cells to lock onto cancer cells like never before. They're literally turned into an army of cancer-hunting assassins.
For a while, CAR-T therapy worked best against blood cancers. Solid tumors were a much, much tougher nut to crack, but that is changing, and fast. The latest data shows these CRISPR-enhanced CAR-T cells are now being sent into battle against a whole host of solid tumors, including some of the absolute deadliest, like lung and pancreatic cancer. This is a massive expansion of what this living drug might be able to do.
So we've seen how CRISPR can engineer our own cells, but what if we could use that same incredible power to engineer entire organs? This brings us to one of the boldest, most audacious ideas in all of medicine, solving the organ shortage crisis by transplanting organs from animals. Welcome to the wild world of xenotransplantation. Now, this might seem like it came out of nowhere, but this idea has been a dream for decades. Early attempts back in the day with chimp and baboon hearts failed because the human immune system just violently rejected them. The real game changer came when scientists focused on pigs and realized they could use gene editing to overcome that massive rejection barrier. So how in the world do you make a pig's heart acceptable to a human body? The secret sauce lies in 10 incredibly precise genetic edits. Using CRISPR, scientists knocked out specific pig genes that scream foreign invader to our immune system, and at the same time, they added in human genes that say, hey, I'm one of you. This 10-gene pig was the master key that finally unlocked the door to modern xenotransplantation. So in 2022 and 2023, the first 2 human patients, both with terminal heart disease and no other options, received these genetically engineered pig hearts. The first patient survived for 60 days, the second for 40. Now let's be clear, while these weren't long-term successes in terms of years, they were absolutely not failures. They were monumental leaps forward, providing priceless data that is paving the way for a future where no one has to die waiting for an organ. So where is all this headed? What comes next? Well, for our last section, let's look at a piece of technology that's kind of quietly in the background, building the foundation for the next tidal wave of cures, especially for our most complicated diseases. Okay, prepare yourself for this one. We are talking about brain organoids. What are they? They are tiny 3D structures grown from human stem cells that actually self-organize to copy the structure of a developing human brain. Let me just say that again. Scientists are growing mini brains in a lab dish. This is a concept that is truly pushing the boundaries, allowing us to study the human brain in ways we never, ever thought possible. So why is this so important? Well, think about diseases like Alzheimer's or Parkinson's or ALS. You can't just take a biopsy from a living patient's brain to see what's going wrong. But with these organoids, you can. We can literally model a specific patient's disease using their own cells, test new drugs on their mini brain to see if something works, and find totally new ways to attack these diseases. This is the research engine that is going to power the cures of the future. All of these breakthroughs, from curing sickle cell to weaponizing T cells, lead to a really simple and powerful conclusion, which is summed up perfectly by this quote. This is no longer academic research, it's a functioning therapeutic category. Gene editing is here. It has officially arrived. It's real, it's working, and it's already saving lives. And that leaves us with one final, kinda mind-bending thought to close on. We've just seen how science is learning to cure genetic diseases that have plagued humanity for centuries. We're on the verge of replacing organs with custom-made ones from animals. We can now model the human brain in a dish. If all of that is happening right now, what does the word impossible even mean for the medicine of tomorrow?